Hello everyone, and welcome to Linux Forensics here at Pen Tester Academy. In this video, we're going to talk a little bit more about using GDB in order to investigate unknown files. In particular, we're going to talk about things like the info functions in GDB that you can use in order to get some more information. So if you go into GDB and you just type info, you'll be greeted with a list like this that tells you all about the different things that you can get information on, such as addresses, registers, arguments. There's all kinds of stuff. Breakpoints, checkpoints, classes, if you have them, Fortran information, exceptions, files, extensions, the floating point unit. A lot of these things are not terribly interesting, but here's one that certainly is. Functions. So functions will give you all of the function names in a program. You can also get local variable information. Another popular one is registers, if you're actually running a program, which we haven't done yet. So far, we've just looked at our programs, and we will be ready to run them soon. You can also get information on the source files for your program, which we typically don't have if you're doing some sort of reverse engineering. And you can see there's quite a bit of stuff here. So I've already loaded up our bind shell. So I'm going to go ahead and type info functions. And remember that you don't have to type the whole word. So if I just type info func, it would work. I can also hit tab, and it will tab complete that for me. And here I have a list of some of the functions in this program. So it starts out with a init. A init is a standard function that gets called in order to initialize the program. This actually gets compiled in and called before the main gets called. All of these that end with @plt are external functions. So those are part of that table that we viewed earlier, that segment that had nothing but a bunch of pointers to other functions and a bunch of jump instructions. So we have put character, set socket options is being used, write, get process ID, file close, stir length, system. We saw that there was a system call, htons, dupe2, send, memset, close, read, fgets, and stir compare. So again, this is a little bit of deja vu from when we were running ltrace and strace, although it's slightly different. Here it's just giving me a list of functions that are in this file. And if I hit return, I will see some more. fprint, malloc, fflush, listen, bind, popen, fopen, b0, accept, exit, fwrite, fork, stir, socket. Here's another standard one, start. Start is where the program begins. And now we start to get into our local functions, or functions that have been defined here. Notice they don't have the @plt at the end of them. So there's a function called deregister tm clones, register tm clones, do global detours aux, which is sort of a built-in thing, frame dummy, end malloc, daemonize, write pid to file, log file, main, and some other functions as well. So as we saw last time, you can disassemble a function by giving its name. So if I wanted to disassemble end malloc, for example, I could just type disassemble and malloc, and it will allow me to see what's going on with this function. Now, I didn't actually close this, so recall that you might want to set disassembly-flavor intel. You might want to make that call when you start up. Otherwise, you'll see something that looks really confusing. It's going to look like AT&T style. So here we can see what's going on in this particular function. It's going to push the frame pointer, move, the stack pointer to it, subtract hex to 0 or 32. That's its stack. And it's going to move some things onto the stack. Does a comparison, does some math, calls malloc, does some more moving around, and it's a pretty straightforward function. You can see it calls memset, and then when it's done, it calls leave and return. So again, if you don't know what some of these things do, definitely look at some of those shell scripting and assembly courses here at Pentester Academy. Essentially what this does, return is pretty simple to understand. It just returns to wherever it was called from. What leave does is leave is a cleanup function. It's going to clean up the stack and put it back the way it was. So let's have a look at a different program and see if we can find out anything new. So we're going to go ahead and load up in GDB, Xingxi, root shell, and I will set disassembly, flavor, Intel, info, functions, and once again it starts with init, puts, get PID, fclose, system, snprint. This is a string print function that is limited to n characters, so a slightly safer version of sprint. Dupe, memset, stir compare, fprint, malloc, fopen, exit, fork, start. And here we start getting into our local functions, deregister tm clones, register tm clones, frame dummy, and malloc, daemonize, write PID to file, log file, main, etc. So this is looking fairly similar to the other guy. Once again, if I disassemble main, I'm going to see some pretty standard stuff. Here's a preamble, again, with the stack pointer and the frame pointer. Calls to nmalloc, snprint, etc. So this is a very similar program to the other guy. I can disassemble nmalloc, and I can see that it looks to be the same as in the previous program. Finally, let's have a look at a reverse shell. Here we see the same kinds of things. A couple of new things. inet address, fopen exit, connect, fwrite fork, socket. So now we see some networking functions being loaded. Deregister, register, frame dummy, daemonize, validate IP4 octet, main, etc. So if we disassemble main, we'll see very similar stuff. So here it's going to allocate 32 bytes on the stack, and it's going to do a check. It's saying, let's check and see if you passed in an argument. So here, notice what's going on. It says you want to compare, right here. We're going to compare 1 to this value. And if greater, I'm going to jump over this call to print usage to this value here. In other words, if you didn't give me enough stuff, we've seen this before, it's going to complain and say, sorry, you were supposed to give me an address. So here we can see what's going on. Another function call here to validate the IP4 address. Now recall that when I tried to give a domain name, such as localhost, this failed. And the reason that it failed is that this program is only expecting a raw IP address, not something that has to be resolved. We have another comparison. We say, is this value equal to 0? If it is, then we're going to jump ahead a little bit. Main plus 85, which is 400 bad. So let's see what that is. We're going to jump here, and call print usage again. In other words, we're going to complain because, yes, you did pass me something, but it wasn't valid. Otherwise, we would continue here, and here we're jumping over that call. We're now ready to call daemonize, write PID to file, etc. Beyond this, it's going to require us to actually run this program, which I promise we're going to do soon. I just wanted to step through it first and kind of give you an idea what might be going on before we try to actually run this in a debugger. So we can see this main method continues for a little bit and then it ends. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you soon.